Okay, yeah, let's jump into it. So, I noticed yesterday, it's kind of silly. I ended the stream like I was right in the middle of some stuff, and then I was like, oh yeah, it looks like we're just out of time. Um, and then I ended the YouTube stream, and I exited out of Discord, and then I looked at the video that had just published, and it was 30 minutes long, and class is supposed to be 45 minutes. I ended 15 minutes early yesterday, and it's just like a brain fart. I just saw it was like, oh yeah, it's almost 3 o'clock, and it's like, oh, 3 o'clock is when it's done, but it's actually we finished at 3:15. So sorry about the short video, but I think. I think it was fine. I mean, it seemed like it was kind of a natural place to end, but I did have it would have been nice to have an extra just few minutes. But I did cover everything that I wanted to. So today, what we're gonna do is just first of all admire this great picture of Goose, and yeah, the answer to yesterday's exit slip was yes. It was absolutely Goose's birthday. So I got a lot of responses on that, so that's fantastic. And let's see. So today, what we're gonna do after this little appreciation bit. Oh, and look who just decided to show up. I don't know if you can see her. Yeah, she's right here. Say hi, Goosey. Yeah, she's 3 now. So what we're gonna do is we're gonna sort of take what we learned yesterday about. Okay, get off the iPad now. You gotta go. We got it. What we're gonna do is we're gonna take what we learned yesterday about finding the least common multiple of two numbers and using that as a common denominator, and that's really what we're gonna be doing today. So let's just start fresh. Let me open up our book so I can have a few good examples to work with. Actually, you know what? I think what I'll do is. Yeah, I'll start off with kind of more of a I'll start off with my own example, one that I've kind of been thinking about in the back of my head for a little while. Okay, what I'll do is we're gonna start off just with a couple examples so we can draw connections. So yesterday there was like a lot of theory, right? It was just like a lot of writing and everything. Today I think we're just gonna do some examples, but I'll try to build the examples up in such a way that we're gonna be working with an example that's really similar to what we did yesterday, and we'll kind of take small steps until we actually have kind of a bigger problem to worry about. So let's see. I'll try to cut this in half like this, and then I'll zoom in. Okay, perfect. Is that good? Yeah, there we go. Okay, a little more there. Okay, perfect. So what we're going to talk about is adding fractions. So that's kind of the first one. Maybe what I'll do is I'll actually just number these. I'm going to number these this time instead of writing EG, because I kind of want it to have some kind of progression here. So the first question that we're going to do is just a straightforward one. So this is just adding two fractions. So what we'll do, let's have 1 over 15, and for the time being, I'm going to keep the numerator at 1 just to keep things simple. And then as we build up, we'll start looking at some examples that have a different numerator. So let's say that we want to add 15 plus 1 over 15 plus 1 over 10. Okay, so we're looking for the least common multiple. So I'm just gonna write 15 over here. I'm gonna write 10, and 15 is made up of 3 and 5, and 10 is made up of 2 and 5. Right? So the least common multiple I'm gonna have to have. Well, I'll have 3 here. So there's my 3. I'm gonna need a 5. Yeah, and that's that 5 and that 5. And then I'm going to need a 2 as well. So, and that's that 2. So if I have 3 times 5 times 2, that will be a multiple of 15, and that will be a multiple of 10, right? And maybe I should actually do these in different colors. So oopsies. Oops. There we go. Okay, so just to give you a good idea of how these relate, so 10 is going to be found in these two numbers, right? Because 10 is 2 and 5, and 15 we'll do in green. So 15 is these two numbers here, right? So there is some overlap, right? There's definitely going to be some overlap, but the important thing is that 15 is 3 times 5, right? So this 3 times 5 times 2 is a multiple of 15. So 3 times 5 times 2, I believe that's 30. That's going to be a multiple of 15 because it's got the 3 and the 5 in it. It's going to be a multiple of 10 because it's got the 5 and the 2 in it. And we couldn't find any number that's smaller than that, because if we removed any of these factors, if we removed any one of those factors, then it wouldn't be a multiple of one of our numbers. So what we're going to do is we're going to say, okay, well, this is going to be equal to something over 30 plus something over 30. Okay, and now we have to figure out what's what. So in order to turn 15 into 30, I'm going to have to go back and maybe I'll change colors here so you can see that I'm adding to this. So in order to turn 15 into 30, I got to multiply it by 2. So I put the 2's there. And in order to turn the 10 into a 30, I have to multiply these by 3. And well, 2 times 1 is 2, and 1 times 3 is 3. And there you have it. 1/15 plus 1/10 is 5/30ths, and we can reduce that, right? So we'll divide both of these by 5, divide by 5, and that's equal to 1/6. Okay, so that's how we would add these two fractions, right? Now the important thing to notice here is, and this is kind of a subtle point. And I want to show you just one sort of pattern that we're going to be seeing, that our denominators are going to have a very particular form here. They're going to have, each denominator is going to have 2 factors. Okay, in this case the 2 factors were 3 and 5, and in the other case the factors were 2 and 5. Another thing that you'll probably be able to recognize is that one of those factors is going to be the same. Okay, that's going to be the pattern that we're going to be seeing here. Okay, and that's kind of what I'm trying to build up, is that we're going to do a couple examples where we have just integers as our denominator, right? And those integers will be factorable. We could factor those into smaller prime numbers, and there's going to be 2 prime numbers in these examples. Now, of course, you can have as many as many prime factors as you want in your denominator, and you would still do the same process. But the examples that we're going to see, because I want to sort of model questions that we're going to start doing very shortly, in which case there will be 2 factors, because the whole idea is that what we're trying to work up towards is to have a denominator that is a quadratic, right? Something like this. So and in this case we can see, well, maybe this is a bad example. Maybe I'll do 7 and 12. So in this case we would have x plus 3 and x plus 4, right? And those would be the factors, and that's kind of what we're building up towards. So and all the quadratics that we've looked at are well, I shouldn't say that, but the quadratics that we're interested in are factorable. We can factor them into 2 smaller factors, and also there's only 2 factors in a quadratic. And that's because the highest exponent is 2. We could have a cubic, like x cubed plus 3x squared plus 3x plus 1, something like that. You could have a cubic, in which case you would have 3 factors, but we're not really there yet. Right now, grade 11, it's just all about quadratics that have 2 factors. So that's why the examples that we're going to do with integers are going to be integers whose prime factorization is 2 prime numbers. Okay, so I hope I'm not making it more complicated than it needs to be, but I'm just trying to sort of illustrate a point here about what we're going for and what the whole point of this is. Okay, just got a little message here. Give me 2 seconds. Yes. Okay. Okay, let's do another example. So let's try one that's maybe slightly a little more algebraic. So let's do this one here. So I'm going to do question 2, and I'm going to add 1 over x times y plus 1 over y times z. Okay. And I think that it's important just to state here some of the non-permissible values. So here, the NPVs are x equals 0, y equals 0, and z equals 0, right? Those are the three values that x, y, and z are not allowed to be equal to. So just to get that out of the way. So assuming that all of these variables are non-zero, let's see what we can do to add these. Well, let's think about the least common denominator. Okay, so the least common denominator, well, let's think about the factors that the least common denominator can have. Well, the factors that xy has are x and y, right? So we definitely need x and y in there. And the factors that yz have are y and z. So we're going to need y and z. But we already have y, so let's just have z. So in this case, let's do this denominator in green, right? This xy is in our least common denominator, and in blue we'll have yz. Yz is in our is going to be in our denominator as well. So let's finish this one off. So I've got 1 over xy plus 1 over yz. Well, the denominator is going to be xyz, right? So we'll have 2 with xyz in there. And, well, now I have to go back and say, okay, well, in this first fraction, how do I turn this xy into xyz? Well, I multiply the top and the bottom by z, right? And in the second one, I'm going to have to scooch this one over a little bit. There we go. And in the second one, how do I turn this yz into, xyz? Well, I multiply the top and the bottom by x, right? So basically multiplying it by x over x. And I can do that, I'm allowed to do that because I already said x is not equal to 0. I could also do this because I already said that z is not equal to 0. So I'm not breaking any rules. Okay, so if I, oh, okay, go ahead. Yes, are you saying, like, can you just write something like this? Right? You could do that. Yeah, you could do that. I'm not going to do that. If you understand that you can do that, that's fine. I prefer to write it like this because as a teacher, I just want to make sure that I'm illustrating every step. If you'd like to skip this step, that's fine. Okay, so in any case, simplifying this portion, we are going to do z times 1, which is just z. And then in this portion right over here, we're going to have 1 times x, rather, which is x. So all in all, now we can add the numerators. And a student was just, if you weren't on Discord, a student was just asking if they could go straight to this, in which case it's yes, if you're comfortable with it. We got z plus x. I like writing things in alphabetical order. You don't have to, but I prefer to write x plus z instead of z plus x. I think it looks just a little bit better. So this is x plus z over, oops, and I guess the denominator doesn't have to be that big anymore, x, y, z. Okay? So that's how we would go about that question. And you can probably see the development of where we're going with this, right? Like we started off with just simple whole numbers. Those whole numbers have 2 factors. Now we went into sort of a more abstract idea where, okay, we still have a denominator that has 2 factors in it. Let's see what the least common denominator would be, in which case we got x, y, z, right? Let's try one that looks like this. Okay, and these ones are harder for me to generate on my own, so I'm just going to copy a couple questions from the book. I think we're on chapter 6, 6.3, I believe. Oh, no. Oh, no, I'm still in chapter 7. That's why it doesn't look good. Okay, where are we? 6.3. Yes, here we go. 6.3. Okay, I'm going to do not that one. Not that one. Here we go. I'm going to do this one. Okay, question 3. X minus 1 over x squared plus x minus 6 minus x minus 2 over x squared plus 4x plus 3. Okay, cool. So that's what we're gonna try to add today. So right off the hop, you could probably say, well, these have different denominators, so we have to find a common denominator, right? So that's what we're gonna do. The tricky thing is, though, like in this last question over here with like 15 and 10, that is very straightforward to factor, right? And then you can find the least common denominator really easily. This one is a little more challenging to factor. So let's see what we can do. So, but the thing, like, we know how to factor it. We can factor it. And just to give you a little hint with these questions, kind of a little pro tip, these numbers often show up. I'm not saying that they have to, right? Because these, like, the numerator typically has nothing to do with the denominator. But oftentimes you'll find that these numbers show up. Not always, but sometimes they do. Okay, so just those can be clues if you're looking for, like, when you're on the hunt for numbers. Sometimes take a look at the numerator; they might give you some clues. Anyway, okay, so let's factor the first denominator. So we're gonna factor x squared plus x minus 6. Okay, so I'm gonna just say that that's what, minus 2 and positive 3. So x minus 2. X minus, or plus 3. Oops. 3. There we go. Okay, so that looks good. Now we're going to factor the other one. Factor, what is it? X squared plus 4x plus 3. Okay, and this is going to be, what do I get? That's going to be plus 3 and plus 1, x plus 3 and x plus 1. And look at that. You can probably see where this is going, right? These both have x plus 3 as a factor, right? So that's going to be a factor. That's going to be like a repeated factor in this among these, right? So when you're finding the least common denominator, you're only going to need one of these, right? You don't need them both, right? Just like before here, we didn't need 2 5s, right? In this denominator, we had in 30. 30 is a nice number here because it's got both 3 and 5, but it also has 2 and 5, right? Which means that 30 is going to be a multiple of 10, and is also going to be a multiple of 15, even though it only has 1 5 in it. And it's because 10 has a 5 in it, 15 has a 5 in it. Neither of them need 2 5s, so you don't need 2 of those 5s in your least common multiple. So just like in that sense, the LCM is going to be, well, I'm going to need x minus 2 and x plus 3, x minus 2. You can always just sort of copy one of them, right? Because you know that all of these are going to be needed, but also all of these are going to be needed. So in which case, I've already got my x plus 3. So there's my x plus 3. Now I need an x plus 1, and that's your least common multiple, right? So that's what our denominator is going to look like. Now, just to sort of go with our color coding, I'll do one red and one green. So the green one is over here. So certainly the LCM is a multiple of our green denominator, and our LCM is also a multiple of the red one, right? So both of these are multiples, or sorry, this least common multiple is a multiple of both of the denominators. So this is not only our least common multiple, I could also call it the least common denominator, because that's the denominator that we're going to use. So let's go ahead with this. I'm going to copy the question down one more time, just so I'm not losing track of it. So what is it? X minus 1 over x squared plus x minus 6 plus x minus 6 minus x minus 2 over x squared plus 4x plus 3. Okay, Now I can zoom, I can go up a little bit. Okay, perfect. So this is equal to, well, we already figured out that we can factor the denominator over here to x minus 2 over x plus 3. And I'm going to have to, ooh, I'm running out of room here. Give me 1 second. That's better. Okay. And I'm subtracting x minus 2 over x plus 3 times x plus 1. All right. And now what we're saying is, okay, well, this is going to be my least common denominator. So this is going to be, and I'm going to have to sort of make this equal sign back over here. So I usually like to have my equal signs one on top of another, but we're going to have to make do. I'm sure you'll survive this one. So let's make the denominator, what's it going to be? X minus 2 times x plus 3 times x plus 1. Okay, so that's going to be my first fraction. Then I'm going to subtract the next fraction, which is going to have that same denominator, x minus 2 times x plus 3 times x plus 1. I'm wondering if my head is blocking that. No, it looks like it's okay. I'm getting a better sense of where my head is supposed to be. It's like around this area, I think. Okay, so that's what my fraction is going to look like. Now I have to go over here, and I'm going to start writing in a different color so you can see where I'm adding my new thoughts. So I'm gonna look sort of in this area right here, and I'm gonna say, okay, so I need to make this first fraction have x minus 2. Yeah, it's got x minus 2. It's got to have x plus 3. It's got to have x plus 3, and it also has to have x plus 1. Oh, okay, so that's what I'm missing. I need an x plus 1 in here. So in order to do that, okay, I'm also gonna have to make a little more room here. I'm a little bit squashed over here. And pardon me, okay. So in order to have an x minus 1 in the denominator, I have to have it in the numerator as well. So I will multiply the top and bottom by x plus 1. X plus 1. I think I said x minus 1 a second ago. That's not what I meant. And don't forget, since we're multiplying it by the whole numerator, we've got to add brackets around that numerator. Okay? And furthermore, and now I'm really running out of room, I'll just really have to squish it in there. The x minus 2. Well, let's take a look at the denominator here again. So I need x minus 2, x plus 3, and x plus 1. So right off the hop, I don't have x minus 2. So I'm going to need x minus 2 over here, and I just really squish it in there, and I've got x minus 2. And remember, you're multiplying it by the whole thing. So yeah, and the x minus 2 that I'm talking about is not this x minus 2. This x minus 2 just happens to also be x minus 2. The x minus 2 that I'm talking about is this one, right? We need this as a factor, we need this as a factor, and we need this as a factor, right? So here's my x minus 2. I just introduced it. I've got x plus 3, so I'll give myself a check for x plus 3, and I've got x plus 1 as well, so I don't have to worry about any more of those linear factors. So let's take a look at what our numerator is now. So our numerator is now going to be, well, I did x plus 1 times x minus 1, so there's my numerator over there. My denominator is now x minus 2 times x minus 2. Okay, now we're going somewhere. So we have a lot of algebra ahead of us. Like, we not only did we just do a bunch of algebra, we're going to continue doing lots of algebra. Believe me, this is a big question. So let's finish this off, or at least let's take it to the next step. So the next step, I'm going to simplify this first numerator. So I've got x plus 1 times x minus 1. Well, I've got x squared. I've got negative x. I've got positive x, and I've got negative 1. In fact, I should have known that ahead of time. This is a difference of squares, right? This is a difference of squares. I'll write that. This is a difference of squares, right? So this is actually x squared minus 1. There we go. This is x squared minus 1 as the numerator of this one. Okay, and I've got x minus 2 times x plus 3 times x plus 1. like as a rule of thumb, do not expand the denominator. Okay, don't expand the denominator. Leave it factored. Okay, because that would be a hard thing to factor again, right? If we can leave it in factored form, like we may be able to cancel something out in like later on down the line. Okay. Okay, so the rest of the denominator, we're going to subtract whatever this is. So I'm going to subtract this. I'm going to put brackets around it just to remind myself that I am subtracting this, right? It would be very easy to lose sight of this minus sign, right? That's a huge place where you can make a mistake. So this is going to be a perfect square. So this is going to be x squared minus 4x plus 4. Okay, I'm going to have to extend this denominator out a little bit, and I'll center it so it looks pretty. Aha, perfect. Okay, so that looks okay, and I'm actually also gonna move this around. Sorry about this. And I'll erase this, and I'll do this. Do not expand the denominator. Okay, so now I can write one more line on this page before I have to start a new one. So we're going to expand this now. So in other words, I'm going to just distribute this negative sign throughout the brackets over here. So like I said, we've got lots of algebra to do, and I'm just going to stick to one color for the numerator now. So I've got x squared minus 1 minus x squared, and then this double negative makes it plus 4x, because remember, I'm subtracting this entire denominator. So every sign that I get here is the opposite sign because of this minus. So next up I've got negative 4. Okay, and all of that is over x minus 2 times x plus 3 times x plus 1. Whew, getting somewhere. Okay, now let's simplify the numerator a little bit more. We've got some like terms. We can see that this x squared cancels with this negative x squared, and that leaves us with 4x, and then we've got minus 4 and minus 1 is minus 5. So I've got 4x minus 5 all over x minus 2 times x plus 3 times x plus 1. And that, I believe, is our final answer right there. Okay? So this is a big question, right? This took like quite a bit of work. You can see it took about twice as much work. No, wait, like 3 times as much work as the past 2 questions, right? And that's just due to the nature of dealing with polynomials and quadratics and that kind of thing. There's a lot of factoring and pulling things apart, and then when you add them together, it's all sort of combined and mixed up and everything, and then you have to simplify it and expand it and factor it and do the whole process again. You could also imagine if the numbers were a little bit different. You could imagine a similar question where like maybe this is a quadratic, right? Maybe the final thing that you're left with is a quadratic. Your numerator is a quadratic, in which case you could factor that quadratic, and then maybe you could cancel with factors in the denominator. Right? Like maybe in an alternate universe, the question could have landed with something like x squared plus 2x plus 1 in the numerator, and maybe you would have x minus 2, x plus 3, x plus 1, right? In which case, this numerator would factor as x plus 1 times x plus 1, right? All over x minus 2, x plus 3, x plus 1, and then this would cancel with that, right? So what I'm trying to say is that there's lots of different possible strategies that you'll have to develop as you progress through these, right? It's not like every single question is going to be exactly the same, right? You're going to have a lot of different situations that have drastically different procedures, right? And the whole point of this is to understand that you can factor these polynomials and they act the same way as an integer, right? So I mean, in its heart, this question isn't any different than question 1. question 1 was just about whole numbers. Question 3 was, you know, you were adding, well, in this case, we're subtracting fractions, right? Just the fractions had variables in them. So I'm starting to lose my voice. I've been doing a lot of talking today. I'm gonna get some water, and then I'm gonna give you a problem so that I can give my throat just a little break, and then we'll do an exit slip. So yeah, I'll be right back. Just gonna get some water, and then it'll be your turn. Hold on. All right, thanks for your patience. Okay, your turn. How about this one here? Okay, made that fraction sign too big. Okay, I'd like you to try this one. I'm gonna give you maybe, let's say 9 minutes. I'm gonna give you 9 minutes for this one. Okay. Oh, heck yeah. Yeah. And I forgot to do that with this last one. NPVs. NPVs. For the last one, you can just look at the denominator right there. NPVs in this case were x equals 2, x equals -3, and x equals -1. Right? Yeah, good point. I forgot to mention that. So yeah. So I guess I'll give you some instructions. I'll say add and find NPVs. Okay. I'll give you 9 minutes. Oops, there we go. Starting now. Boom. Excuse me. Thank you. I'm wondering if maybe 9 minutes was a lot of time for this one. How are you guys doing? Are you almost done? Okay. If you're like watching on YouTube and you're not done yet, you can just pause the video. Just wanted to make sure you had enough time, but I think this is more than enough. So let's factor this one. So I'm gonna factor this first fraction. I'm gonna factor x squared minus x minus 12. And that's equal to x minus 4 times x plus 3, right? And again, like I said, like look around a little bit. There's probably an x plus 3 in there because that denominator is an x plus 3. They wouldn't get you to add these two denominators together, add these two fractions, if they didn't have any sort of common factors. So x plus 3 is going to be a common factor. So the LCD, the lowest common denominator, is going to be x minus 4 times x plus 3. Great. So I've got these two guys, and that's already includes the x plus 3. So that's my least common denominator. So I don't have to change the first fraction at all. The first fraction is just going to be x squared minus x. Oh, sorry, not that. X minus 4 times x plus 3. And this second denominator is going to be the same. It's going to be x minus 4 times x plus 3. And, well, what do I have to do to this one to turn it into x minus 4 times x plus 3? Well, we multiply it by x minus 4. And what I do to the top, I have to do to the bottom. And that looks good to me. So this is on the top right here. We have 3 times x minus 4. And now we simplify, so the numerator is going to be 1 plus 3x minus 12, and the denominator is still x minus 4 times x plus 3. Oh, and there's my timer. I guess I can turn this off now. And let's see if we can simplify that numerator at all. I don't think we can, but we'll try. So that's 3x minus 11. Yeah, I don't see us factoring that, so I think this is it. 3x minus x minus 4, x plus 3, and we haven't canceled any of the factors out, which means that the non-permissible values are all just staring at us right there. We don't have to search anywhere else in the question because none of the factors got like deleted or anything. They didn't get erased, so they're all right there in the bottom. So the non-permissible values are x equals 4 and x equals negative 3. So I think that'll do. For today, what I'd like you to do is for the exit slip for today is, let's add I'm going to get you to do 3A. 3A on page 336. 336. Okay. By the way, this last one that we just did was 6B. This was 6B. I just stole it from the textbook because I'm a pirate. Yeah, so this one was 6B, and I want you to do 3A for your exit slip. And your homework for the day, is questions. Let's do Let's do 1 to 3. Questions 1 to 3, all of them. I think that's 1, 2, 3, 4, 5, 6, 7, 8 questions in total. And that's on page 336. Page 336. So that's your homework for the day. So those eight questions, and then your exit slip is part of that. So if you wanted, what you could do, you could just do all of those questions, and when you get to 3A, then just go back and punch in the exit slip. But yeah, now it actually is 3 it's past 3:15. So it really is time to log out. So I'll talk to you guys tomorrow. Have a good day and have a good one. Bye guys. And goodbye YouTube. You're next. Okay, take care. Bye.